Okay, Year 10, I'm going to do some rationalising the denominator where we only have a single surd. So I'm going to look at questions 4, 5, 6, 7, and maybe 8. Do we have to do question 8? Let me have a look. 4, 5, 6, 7, I'm going to cross off that one. We might do question 8 as well. So let's go back here. So what we're doing here, now remember the whole point of this is because they didn't have calculators. So remember we're doing the last two columns. I'll just go down and I'll work the last column of these questions if you're having trouble. So 4D. Now what we're using, or what we're going to use, is we're going to use the fact that root A times root A equals A. So what I want to do is if I look at 4, I've got root 4, sorry, I've got 4 on root 5. Now, if I want to rationalise the denominator, if I want to make that denominator a non-surd, a rational number, I can just multiply it by root 5. But because this is a fraction, what I do to the bottom, I must do to the top. And I hope you realise that multiplying by root 5 on root 5 is the same as multiplying by 1, which doesn't change anything. When you multiply something by 1, you don't change it. So on the top, I get 4 root 5. But on the bottom, I get root 5 times root 5, and I get 5. Now, why is that useful? Well, because if I'm going to add fractions, and I've got surds in the bottom, it's very hard to make common denominators. But if I've got a rational number in the denominator, it's a lot easier. And that's why we're doing it. Here's 4h. I've got root 2 on root 7. Now, I don't care about the numerator. What I'm looking at is the denominator. I want to make the denominator a rational number. So I'm going to multiply by root 7. And again, if I do it to the bottom, I do it to the top. Root 2 times root 7, root 14. Root 7 times 7, 7. Now don't try and cancel now. You can't cancel with the top and the bottom because that's root 14. It's not 14. Let's have a go at 5. 5D. Well, straight away they make it hard for us. They say, well, they were root 2 over 5. And you go, well, I'm too smart for you. I know that root 2 over root 5 is the same thing. And then I multiply by the surd in the denominator. And I get root 10. And root 5 times root 5 is 5. And I don't change anything. So I'll just check and see if I'm right. So 5D, yeah, root 10 on root 5, 14 on root 7. Was I right with the other one?
Yes.
Yes, I was. So let's go to 5H. And again, they've tried to trick you. We've got root 17 on root 2. Well, you're too smart. You go, well, that's root 17 on root 2. And you're going to multiply by the surd that's in the denominator, root 2 on root 2. We'll put our vinculum in. And that will give us root 34 on 2. Okay, that's too easy. Let's have a go here. So if I get to 6C, what have I got? 3 root 5 on root 2. Well, again, whatever's in the denominator, root 2, 3 root 5, well, the 3 stays there. Root 5 times root 2 is root 10. And I get root 2 times root 2, I get 2. So again, pretty easy. Let's go F. Now remember, you're meant to be doing both columns. 2 root 7 on root 15. All right. Look at the denominator, root 15. Root 15 on the top. 2, 7 times 15, 7 fives are 35. Carry the 3, 10, 105. 2 root 105. Is that right?
Yes!
Thank you. And 15, root 15 times 15 is 15. Okay, when is this going to get hard? Here we go. Let's look at D. 7D. 7D. Now I'm going to do, actually I might do 7F first, because 7D has a little bit of a trick to it. So I'm going to do 7C first. 5 root 7 on 3 root 5. Now, some of you will want to multiply by 3 root 5. Don't. Just multiply by whatever the surd is, this bit here, root 5, because that'll get rid of it. If you multiply by 3 root 5, you'll have a lot of cancelling to do, simplifying. Okay, let's do the top. 5, yep, root 7 times root 5, root 35. And on the bottom, I've got my 3, and root 5 times root 5 is 5. Now, I could have written 15, but I look up the top and I see that, well, I can cancel. 5 and 5 cancel. So I get root 35 on 3. 7C, and we're right. Well, let's have a look at 7D. And I'll go over here. 4 root 5 on 5 root 10. Well, the first thing I'm going to do is I'm not going to try and rationalise it straight away. I know that root 5 goes into root 10 root 2 times. So I'm going to change this up. It's 4 on 5 root 10, root 2. Now, if you didn't see that, don't worry, because you can cancel things out later. But if you make that step first, it just makes it a little easier. Now I have this fraction. I'm going to multiply by root 2 on root 2. Remember, you just have to multiply by the surd. Well, 4 root 2, that's easy. 5 times root 2 times root 2 is 2. I'm going to write 5 times 2. Oh, but why didn't you just say 10? Because, again, I'm going to cancel. It's multiplied. 2 goes into 4 2 times. Now remember, you can only cancel numbers with numbers and surds with surds. So I get 2 root 2 on 5. And if I'm looking at 7D, am I right?
100% yes!
Thank you. So I'll do 7H. See if you can do it before I do it. So I've got 7 root 90 on 2 root 70. Now again, they're trying to be tricky. They're trying to say, wow, you're going to have to multiply by root 70 on the bottom. But we can do a bit of cancelling. We know that root 10 goes into that root 7 times. And root 10 goes into that root 9 times. You could have pulled the 9 out anyway. Which gives me 7 times root 9. Hold on, root 9 is 3. Yes, it is. And I'm going to get 2 root 7. Okay, so now what do I do? Well, Mr. Tonk, the first thing you should do is do that 3 times 7. Now I'm looking ahead. at what's going to happen when I do that root 7 times root 7 on the bottom. You watch what happens. So I've got 7 times 3 times root 7. And on the bottom, I'll get 2, and root 7 times root 7 is 7. And aren't you glad you didn't multiply it out now, because the 7 will cancel, which gives me 3 root 7 on 2. And if I look at 7h, that's the answer. So they do get a little bit more complicated. Let's have a look at question 8. Okay, root 3 minus root 5 on root 2. And that's 8d. Root 3 minus root 5 on root 2. Root 3 minus root 5 on root 2. Well, again, just look at the denominator. That's all I'm worried about rationalising. So I'm going to multiply by root 2 and root 2. Now I've got to remember that these things are grouped because they're on top of the vinculum, which means I've got to do root 2 times that and root 2 times that. Okay. Root 2 times root 3, root 6. Root 5 times root 2, root 10. Root 2 times root 2, 2. Now don't try and cancel it. The denominator is a rational number, whereas the top numbers are surds. And 8d, there we go. All right, I'm going to jump now to 8l. And then I'm going to let you have a go at the last ones. So 3 root 10 plus 5 root 3 on root 2. And that's L. Three root 10 plus 5 root 3 on root 2. Just double check. 3 root 10 plus 5 root 3 on root 2. Again, all you're going to do is look at the denominator, root 2 on root 2. And again, we're going to think or we don't have to think, we know that is grouped. And we have to do root 2 times both of those things in there. So 3 root 5 root 2. Oh no, I won't do it like that. I'll expand it out for you later. So 3 root 10 times root 2 plus 5 root 3 times root 2. And all over I get 2. I'm lucky here though, because I know that root 10 is root 5 root 2. So here I get 3 root 5 root 2 root 2, and here I'll just multiply this out. 5 root 6, there's nothing I can do with that. And I've got a 2. Well, root 2 times root 2 is 2. 2 times 3 is 6. So I get 6 root 5 plus 5 root 6 on 2. And that's 8l. 6 root 5 plus 5 root 6 on 2. Am I right?
Yes!
Yes. Now, don't be tempted to cancel that 2 into that 6. You can't, because there's an addition there. And you can't cancel when there's an addition. You can only cancel when things are multiplied. Anyway, that's questions 4, 5, 6, 7, 8.